Good morning, everyone. This is Sepa, and I am the head of marketing and product development teams at Sterlitech Corporation. Thank you, everyone, for joining us this morning. One thing I would like to ask all the attendees is to put their microphone on mute so we can all listen to the presentation. And we have time for questions at the end of the presentation. So you can unmute your microphone at the end or type in your questions in the chat section. And Sarah and I will be happy to answer the questions at the end of the presentation. And if we don't have enough time to answer all the questions, we will make sure we get back to you on email. All right. So this morning, Sarah and I will be presenting about Sterlitech products and mainly focusing on the skid mount membrane filtration systems. I have Sarah Ozary here with me. She is the application engineer at Sterlitech.
Hello.
Hello, everyone. Welcome to our first webinar.
All right. Just to make sure everyone can see the screen, if you can confirm you can see the screen and you can hear as well, then we can start the webinar.
Just a second.
Okay. All right. So today I will briefly introduce you, provide you a brief introduction about Sterlitech as a company. And then we discuss about skid mount membrane filtration systems, their applications, their features, and we will also present one of our most recent designs, which is called Convertible Skid. And Sarah is going to go through the skid design, features, and system components. And she will also be happy to answer your questions. And I will also be here if you have any questions for us. So Sterlitech was founded in 2001 and with a unique product line, which was silver membranes. And we grew as a company over the last few years. And last year, we got certified for ISO 9001 to 2015. Our mission is to equip scientists, entrepreneurs, and visionaries with filtration products to transform ideas into reality. What do we offer? Sterlitech mainly offers filters and filtration products. We offer membrane filters, both organic and inorganic membranes, and we offer membrane test cells that you will use to test those membrane filters. We also offer fully assembled systems that have those membrane test cells in them. What you see on this slide is one of our test cells, which is a cross-flow cell that accepts polymeric membranes, flat sheet membranes, and its feed solution will be circulated on one side and permeation occurs through the membrane. We have different types of test cells. If what you see on this slide is all the different cells that we offer. And the first one on the left is called Discoverer, and it's a stirred cell, dead end type of cell, with only about 300 milliliters capacity on the feed side, and the membrane area is only about 14 centimeters square. Going through Innovator, Explorer, Developer, those are cross-flow type cells, so feed will be circulated on one side tangential to the membrane surface, and then permeate gets collected on one side. The difference is the membrane area, and as you can see, CFO16, the Innovator family, has the smallest area and Developer has the largest area. These are all available in different materials of construction, so they can be stainless steel, Delrin, etc. And finally, the largest test cell that we offer is 1812, and we do 2542, and those are spiral wound membrane elements and housings, and you can see the membrane area is significantly larger. And finally, we offer pre-assembled systems. These systems, as you can see on this slide, have those test cells installed on them already. So this is like a plug and play kind of system. So when you receive the system, you just plug it in and test your membranes in them. And this is basically what we're going to present to you today. So what are the main features or benefits of these systems? One of the main features is that these systems have been fully assembled and tested here, and researchers can just plug and play and test their membranes in them, and instead of spending time on sourcing pumps and fittings and all the other sensors and features that they need to build a full kind of filtration setup or filtration rig. These are highly customizable for chemical compatibility, so we can change the material of the construction based on your application. And we can also integrate pre and post filtration systems in these fully assembled kind of systems, either pre-filtration or post-filtration, before and after the test cells that we offer. And finally, these are modular systems, and you can add or remove test cells to the same system while you keep the same feed tank and pumps and sensors and everything. These are also available in both 110 and 230 volts, so they can kind of be used globally. What are these systems used for? What do researchers use these systems for? These systems can be used for a variety of different applications: processing water and wastewater, food and beverage applications, chemicals treatment, pharmaceutical, or even treating radioactive waste. As you have noticed, since we started talking about these skids, I've shown you a few different kind of designs for these systems. The one on this slide is a system designed with pre and post filters, and they have Sterlitech test cells on them. This is an analog system, and Sarah is going to present to you more features and system components on these kind of systems. These pre-assembled systems can be designed in a pressure-driven mode. What that means is that there is a pump to pressurize the feed side. Feed solution is circulated tangential to your membrane, and then permeate goes through the membrane and gets collected. And this is a typical system design for a pressure-driven filtration system with a pump to pressurize the feed side. And then on this one, you have a 2540 housing, which is a cross-flow system, and then you collect permeate. The other alternative is to use these systems for low pressure applications such as forward osmosis or membrane distillation. The main difference is in addition to low pressure, you actually have two streams or two solutions circulated in the system. You have feed solution circulated on one side of the membrane, and you have draw solution or cold solution circulated on the other side of the membrane. And then you have permeation through the membrane. As you can see when you look at the system, the main difference is you have two pumps, and you have two low pressure pumps because you don't need high pressure in these systems. The particular system on the screen is designed with two acrylic cells, as I was showing when we started the presentation, with a smaller one and a larger one, both cross-flow version. These systems are one of the main components in any research or research labs, and they are used for different types of applications. However, let's say you start with one type of system, and over the years, your focus or your research focus changes, and you need a system with maybe two pumps now. But cost of sourcing multiple systems can be significant and challenging to secure, especially sometimes in academia, coming from academia. So how about one system, one pre-assembled system that can do both high pressure or low pressure kind of application or filtration? So with that, I hand this over to Sarah to present to you more about our pre-assembled systems.
Hello, everyone, again. I would like to take it over from Sepa from here and respond to the question of how about one system can do both. Yes, there is a system that we call it a convertible system, and that system is designed to operate in pressure-driven modes such as macrofiltration, ultrafiltration, nanofiltration, and reverse osmosis. And also it can be used in an osmotically driven or temperature-driven mode. If we look at the flow diagram of the system when it is operated in pressure-driven mode, like in start from this slide.
Sarah, you need to go back and start. I think your microphone was on mute. Now they can hear you.
Hello, everyone. Can you hear me again? So I will start from taking over the question from Sepide, how about one system can do both? And yes, the answer to this question is a yes. So we have a convertible system that can be used to operate in a pressure-driven mode, such as macrofiltration, ultrafiltration, nanofiltration, and reverse osmosis. And also it can be used in an osmotically driven or temperature-driven mode. If you look at the flow diagram of the system when it is operated in pressure-driven mode, so like in any pressure-driven membrane process, a pump is required to send the pressurized fluid to the membrane cell or membrane module. So the pump sends the pressurized fluid to the membrane module, and then the pressurized fluid gets in contact with the membrane filter, and the water and the particles that have a size smaller than the membrane pore size can pass through the membrane and and also the larger particles stay in the feed stream. So the concentrated feed stream can either leave the system, exit the system, or it can go back to the feed solution tank to be recirculated in the system. The system, and depending on the type of the application, the concentrated feed can be the final product, such as in the fruit juice concentration, or the permeate can be the final product, such as in water treatment application. The system also has a set of valves to control the pressure, and also pressure and flow sensors to monitor those parameters. If you look at the system, when the system is operated in forward osmosis or membrane distillation mode, in these modes, like two streams of the fluid is required. So there are two pumps involved. One pump is circulating the feed over the membrane, and also the other pump will circulate the draw solution or the cold stream over the other side of the membrane. Like in this particular schematic in here, there is a membrane distillation. So the hot water stream pass over one side of the membrane, and the water vapors permeate through the membrane and get condensed on the other side of the membrane. And it will be mixed with the cold stream, and then it will go back to the to the cold solution tank. And then that's why the weight of the cold solution tank will be increased over time, because the water is permeating through the membrane. Now that we talked about the system flow diagram, I would like to introduce the components of the system and the features of each component. The main component of the system is a high pressure pump, and this pump can go to up to 1000 psi, and this is a positive displacement type of pump. So the fluid never drops at high pressure. And also the system also has another pump, which is a low pressure pump, and that's the reason it's a low pressure pump is that for forward osmosis application or membrane distillation application, there is no pressure required, and this pump is much smaller, and also it's a low-cost pump that can be used for the forward osmosis application, and this pump can go only up to 80 psi. The other components of the system are feed and draw tanks. Like this particular picture is showing the flat bottom type of the feed and draw tanks, and also the draw tank there is a scale under the draw tank that can be used to measure the weight change of the draw tank, and then the membrane flux can be calculated using those numbers. The other component of the system, which I believe is the heart of the system, is the convertible cell. And like this slide in here shows a better view of the convertible cell. Like the picture on the left side shows the convertible cell where it is in the pressure-driven mode. So the bottom part of the cell has an inlet and outlet port, and also an inlet and outlet port for the feed. And so then the water permeates through the membrane, and then the top part has only one outlet for the permeate. And the second picture in here shows the cell when it is used in osmotically or temperature-driven mode. Like if you see that the bottom part is exactly the same, so it's like one inlet and outlet for the feed, but the top part has two ports, one for the draw solution inlet and the other port is for the draw solution outlet. And the cell can be easily converted from one type to another just by simply swapping the top parts. So that's very easy and straightforward. The other component of a system are pressure control valves. So system has a set of valves that are used to control the pressure in the system. Also, on a digital system, we have a human-machine interface touchscreen, and this touchscreen can be used to control the pump speed and also turn off or turn on the pump. Also, this touchscreen can be used to monitor the real-time data such as the fluid, conductivity, temperature, pH, and also the pressure in the system. The other component of a digital system are Ethernet and USB ports for data collection and monitoring. So the system has two ports, one for a USB connection and the other one for laptop connection. And that USB port can be used to connect a USB memory stick to it, and the data can be easily transferred to the USB memory stick. And this feature is very interesting, particularly when the system is installed in a remote or hard to access area, so that the user don't have to take a laptop each time to collect the data. And also there is another way to collect and monitor the data, and it is to connect the laptop to the panel. So when the laptop gets connected to the panel, a page will be shown on the laptop, and that has two options for the user. If the user clicks on the view logs, it will take the user to another page where the user is able to monitor and also save the data that has been recorded in the system on the computer. And also, if the user clicks on the remote view, they will be able to see the HMI touchscreen on the laptop screen, and they will be able to control the system, such as changing the pump speed or turning on or turning off the pump, and also will be able to monitor the real-time data on the laptop screen. We also have added some safety features to the system. One of them is a pressure relief valve. So if the pressure exceeds the pressure relief valve set, relief valve sets some of the fluid, they divert some of the fluid back to the feed tank, and it prevents overpressure in the system. Also, on a digital system, we have a pump shut-off pressure set point, and then whenever this pressure goes above that set point, the system will automatically be stopped. The pump will automatically be stopped. And these two features are very useful in protecting the membrane or the membrane cell, and also the sensors in the system from being damaged by overpressure. Another safety feature that we have added to the system is the level switch. As soon as there is no fluid in the feed tank, the level switch stops the pump automatically, and it doesn't let the pump to run dry. This slide shows a few two examples of the recent skids that we made. Like the first one in here shows has like two types, two flat bottom type of tank, and also a convertible stainless steel Sepa cell. And this one in here has a conical feed tank and also a flat bottom draw tank. And the cell in here is an acrylic cell, and this acrylic cell has some additional features. So it's not only it can be used for pressure-driven application, forward osmosis, direct contact membrane distillation, but also there is a conversion kit available for this cell that it can be used for air gap membrane distillation application. To wrap up, the system can be used in very different applications, such as fruit juice clarification, milk purification, or whey protein concentration, and also wastewater treatment and water desalination. And thank you all for listening to us, and it's time for questions.
All right. Thank you, Sarah. So we have time for questions. Please feel free to type in your questions in the chat section, or you can also unmute your microphone. And if you have any questions, we will be happy to answer those. So we have first question here, Sarah, which says, what are your scale specifications, maximum weight and resolution?
Yes, we have two types of a scale. One can go up to 6 kilogram, and the other one can go to 30 kilogram, and the resolution of the system is 1 gram.
All right. Thank you, Sarah. So one thing that, if you don't have any questions, one thing that I can share with you is, let me share my screen with you. And, okay. So if you are interested to learn more about the skids, you can go to our webpage. So Sterlitech. And then if you go to our main page, our product, membrane process development, and skid mount membrane systems. If you click on that link, it will direct you to the skid page where you can see different different designs of the systems that we have built, and you can look at the data sheets and look at the specifications of each of those systems. There are also animations and videos which you can take a look at and learn more about that product. And we will send a copy of this webinar to you by the end of the day today or tomorrow. And then you can reach out to me and Sarah if you have any other questions. With that, I thank you everyone for joining us again today, and hopefully we will hear from you with comments and feedback. Thank you. Oh, sorry, there's one last question. Is there any standardized methodology for filtration membrane testing? Do you want to take that question, Sarah? Okay. Can I unmute you, Diane, and then you can maybe tell us a little bit more what you exactly are looking for? Do you have a microphone, or can you type in chat? Okay. So looks like you don't have a microphone, but in terms of filtration membrane testing, typically researchers try to mimic hydrodynamic conditions of larger systems and larger applications in these smaller systems. So when you're thinking about your filtration testing and designing your experimental program, you need to keep that in mind. It's like, what is your objective of testing and what parameters you want to test and look into. And with keeping that in mind, you can design your experimental program and operating conditions. We have a few questions about the analog system, the safety concern, and system capacity. So the analog systems can be designed with different pump capacities, and they can start from around 1.8 gallons per minute, going to 10 gallons per minute. That's kind of the range we usually stay within. And the safety features are to protect the pump and the test cells from overpressurizing. So if you pressurize your system higher than the safe operating pressure range of the different components in the system, you can damage the cell or the sensors. So with the pressure relief valve and the pressure shutoff feature, we make sure that pump stops as soon as the pressure goes above a certain level. And in some cases, researchers have a specific kind of pressure limit in mind for their test, and they don't want to go above that pressure. So again, that will dictate the maximum operating pressure that you will set on your system with the pressure relief valve or the pressure shutoff feature. Did that answer your question? So we have one last question, is product capacity. Okay, looks like that answered that question too. All right. Again, if you have additional questions, you can email me or Sarah, and we will be happy to answer you. All right. All right. Thank you, everyone, for joining today.